This is the explanation video for the 2.4 notes. We're going to have either vertex form or intercept form, and a word problem of some sort where we have various pieces of our quadratic and our goal is to write the equation. So in our first example, we have the path of a performer who's shot out of a cannon, so at a circus or something like that. And we have our graph over here on the side. We're trying to write the equation and then answer this other question about what is the height of the net. Okay, so looking at our graph, we have our y-intercept here, 0, 15. Okay, we also have our vertex point, 50, 35. All right, remember that is HK. And so if you're looking at that, the y-intercept would be able to be used in standard form. 15 is the C. And the vertex is able to be used in vertex form. Most of the time, you're not going to go straight to standard form. So we could write this and figure out our standard form from either vertex or intercept form. But we're going to use vertex form here. So when we write our equation, we don't know A yet. We do know that X is, the H is 50 and the K was 35. Okay. Because we have our y-intercept, which is just another random point on the graph, they have to give you another point here. We can take that, and that is the x comma y that I can use in my equation. Any additional point can be subbed into your equation for x and y. So I'm going to do that and say 15 is equal to a, which I still don't know, times 0 minus 50 squared plus 35. Okay, and now the only thing missing is the a value, which I'm going to have no matter what version of the equation I'm trying to write, whether it's vertex form, intercept form, or standard form, they all have a in the very front. So you're going to have to take the pieces that you know, find a so that you have your actual equation. So I'll go ahead and do that. I'm going to just solve this for a, so move that 35 over. I'll have negative 20 is equal to negative 50 squared is going to be 2,500 times the a, which then makes a negative 20 over 2,500, which does reduce down to negative 1 over 125. All right, I'm going to leave that as the fraction, negative 1 over 125, and write my equation here with that fraction. All right, you could also write it as a decimal, but we kind of talked about a being a whole number versus a fraction, so that's why I'm leaving it. Okay, that is the equation for the graph above. And then we have our second thing that we've been asked to do, find the height of the net. All right, so because I now have, go back to my graph, I have a third point here that I don't necessarily know exactly the y-coordinate there. That's what I'm trying to find there, 90 comma something. Okay, so I have an x, I can sub that in and actually figure out the y that goes with it. It's possibly a fraction or a decimal, but you're just subbing in the x value to get the y that goes with it. All right, so we have all of that. In that parentheses, you'll have a 1600, 90 minus 40 is, or 90 minus 50 is 40. Square that at 1600. All right, plus the 35. And I'm gonna let you finish this out, put that in your calculator, and figure out what the height of the net that they're landing in out here is, and make sure that you are writing feet. All right, we always write our units. So you figure that one out. Okay. Let's do number 2. This time it's not a word problem. We have a point, which is always an XY. And then we have our vertex, which is HK. All right. Vertex form or intercept form in most cases. And because we have our vertex, we're going to do vertex form. So I'm going to do exactly what I did last time and take my X and Y and my H and K and sub all of that in. All right, so this is my form. I know H is 4, K is -9, and then we'll just go ahead and sub in the X and the Y. You could do all of that at once if you want. All right, you have to solve for A. Every single time you're going to have to solve for A. So that means I'm going to add 9. So 11 equals A. -1 minus 4 is -5. All right, so that is 11 equals 25A. And then I have 11/25 as A. On this one, I'm just going to go ahead and convert to a decimal because I can, just to show you what that looks like. If A is a fraction or a decimal smaller than 1, that is the vertical shrink. So when we write our parabola over here, 0.44 is going to go in the very front of my squared parentheses. Okay, that is my equation, and that is all I was asked to do here. All right, if you flip to the back, we're going to do a word problem example with the intercept form, and then another one with intercept form. All right, if you have a graph you have been given, then you're going to read the points that you have. So they have to give you, to use intercept form, 2 x-intercepts. So I'm going to call this one P and this one Q. All right, so I have 4, 0. I have 24, 0. All right, this is P. This is Q. All right, and then I have this other point here, 0, 9.6, which is my additional point that I know X and Y for. It happens to also be the x-intercept. I'm sorry, the y-intercept. So if that is the case, that's great. But you're not going to treat it any differently because we're not writing from standard form. You can take your final equation that you get and turn it into standard form, which we will talk about later. Okay, so intercept form, I have A times x minus P times x minus Q. Remember, it's minus in those parentheses. All right, so here that means I have 4 and 24 being subtracted from the x's. Okay, and then so that's my first part. Then if I go ahead and sub in the 0 and the 9.6 for x and y, A times 0 minus 4 times 0 minus 24, and then go ahead and solve that. So 9.6 equals A times -4 times -24, which happens to be 96. So you have 96A equals 9.6. A is then 9.6 over 96, which hopefully you recognize does reduce. And that becomes 0.1 or 1/10. Right, which means that my equation is 0.1 times x minus 4 times x minus 24. All right, that is part A. My coldest temperature here, if I go back and look, my coldest temperature, I can look at the graph and estimate what that is. It's going to be over here at this vertex point, but I want to find that vertex point. So I could do this a couple different ways. It kind of looks like it's a decimal there, so I'm going to actually do the axis of symmetry equation because I know my vertex point falls on the axis of symmetry. So here I have P and Q, 4 and 24. I know that if I average them together, so add them up, divide by 2, that's going to tell me my axis of symmetry equation. So 14 is that axis of symmetry, which is not exactly on the grid here. But because I know this x value, I can then take it into my equation that I've written, 0.1. All right, subbing in for x, 14 minus 4 times 14 minus 24. And I am able to actually find exactly what that is. So 0.1 there, 14 minus 4 is 10, 14 minus 24 is negative 10. So I have 0.1 times negative 100, which is negative 10 degrees. Let's make sure we put our units. We're in Celsius. So that is our final answer to the rest of part A. The coldest temperature is 10 degrees below 0. Okay, part B, the average rate of change in temperature over the interval in which the temperature is decreasing, and then over the interval that it is increasing. All right, so I'm going to do this in a different color here. B, my average rate of change. That's basically asking for your slope. So you're going to say your change in the y over your change in x. All right, and it asked for this twice, over the interval in which the temperature is decreasing and increasing. So if we do decreasing, I'm going to say D for decreasing. All right, so let's go back and look at our graph. We do know that this point here is 14, negative 10, right there. And then if we're talking increasing and decreasing, that is always half of the parabola for each one of those intervals. The increasing interval is when we hit that minimum temperature and then we continue to rise back up. So that's going to be sometime in the middle of the night as you're approaching morning. The decreasing temperature is going to be as you're leaving evening from the night before into midnight, into, you know, sometime 1 a.m., 2 a.m., 3 a.m., something like that. Okay, so the decreasing here is my left side of my graph. So this side right here is decreasing. So I need on the graph the two different x and y points that I have there, so the outsides of the interval there. So the decreasing, I'm going to take my 0. Let's see. Oh, I think I got that backwards on the answer key. All right, so I'm going to take the 9.6, the change in the y, 9.6 minus the negative 10 over the x's that go with it, 0 minus 14. All right, and that's going to get my decreasing. So that should be getting me 19.6 in the numerator over a negative 14, which worked out to be a negative 1.4 degrees Celsius per hour. So in that decreasing interval of the graph, we are losing 1.4 degrees Celsius an hour. That negative is telling you you're decreasing. Okay, for the increasing, I'll do that in a different color here. Okay, that is going to be my other portion of the graph. So when we start rising back up as we're approaching sunrise. Okay, so for that one, I have two different points. All right, I have 14, negative 10, and I have 24, 0. You're always going to use those outside points. All right, so I need the y's in the numerator. Okay, so this is going to be 0 minus negative 10 over the x's that go with them, 24 minus 14. And then in the numerator, I get a positive 10. In the denominator, I get another positive 10. And that reduces to 1, positive 1 degrees Celsius per hour. So that means you are gaining 1 degree Celsius per hour in that interval. Okay, we can talk about that a little bit more when I come back, but that is basically just finding slope of different pieces of your quadratic. Okay, last one here. Write the equation of our parabola that passes through this point. This is just a random xy point. We don't know that it's anything special, but we do know that we have P and Q over here are x-intercepts. Okay, so because I have the x-intercepts, I am going to use my intercept form, which is this. I'm going to go ahead and sub in my negative 2 and my 4. And remember, that changes signs. So that negative 2 is actually minus negative 2 when I put it in my equation, which turns into a plus 2. All right, x minus 4. All right, and now I'm going to go ahead and take my 2, 5 point and sub in for x and y. 2 plus 2, 2 minus 4. Okay, and I have to find a every single time. That's always going to be your first step once you have everything subbed in. Find a. Okay, so 4, negative 2. So this is negative 8a. And then that makes a negative 5/8 or negative 0.625. You can use whichever version of that you like, the fraction or the decimal. But you're going to write out your full equation. And this is your answer to this question. You'll notice on all of these, I had a decimal somewhere. So that's often a, because we can more easily decide what the intercepts or what our vertex points are. A is a decimal because real life does not always work out to give us whole numbers. So if I had wanted a to be a whole number, I could have had a whole number for a, but then my vertex or my intercepts would be decimals and fractions themselves. So it's real world, something is going to be a decimal in most cases. Okay, you're going to finish graphing if you did not finish those 12 questions from yesterday. Check your answers against the color-coded answer key that I've given you access to now on the calendar. And then we will do a little bit more practice with this when I come back to make sure we don't have any questions about this.